Okay, the following is a video over the 11.5 notes. What we're talking about here is the areas of similar figures. So I want to talk about the formulas and how we get areas of similar figures. So the first thing I want to do is I want to find the area of this rectangle. But before I do that, I know that this is a 1 by 3 rectangle. Okay, so the area of my smaller rectangle, okay, small rectangle, is going to be an area of 3 units squared. Okay. Now this is another similar rectangle to this. Okay. I know that this is a 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 3 by 9. So if I take the area of the big rectangle, okay, then I get an area of 3 times 9, which is an area of 27 units squared. Okay, now this is kind of interesting because we've talked about similar figures before, and I want to talk about our similarity ratio. So similarity ratio. Okay, and our similarity ratio here, going from small to big, is 1 to 3. Okay, similarity ratio, or it's also known as our scale factor, goes from 1 to 3. Okay, so what I know about this is that I can also write this as a fraction from 1 to 3. Okay, and what I know about this is that if I take the ratio, so the area ratio, if I take the small area divided by the big, so if I take my area ratio, I get the small area, which is 3 units squared, divided by 27 units squared, okay, I get this ratio of 3 over 27, and this simplifies down to 1 over 9. Now, what would I have to do? Here's my question. What do I have to do to 1/3 to equal 1/9? And what I end up having to do here is I end up having to do this. I end up having to do, if I square 1/3, and if I square 1/3, that's the same thing as me taking 1 squared over 3 squared, which gives me 1 over 9. Okay, if I take a fraction and I raise it to a power, I have to raise my numerator to that power, my denominator to that power. But another thing, one way to think about it is I could take 1/3 times 1/3, which gives me 1/9. Okay, so you're probably sitting there and you're going, okay, what does all of this mean? Well, what we get here is a formula. Okay, if I take the area of the big figure, or let's say area of the small figure, okay, and divide it by the area of the big figure, then I'm going to get my scale factor, okay, scale factor squared. Okay, I'm going to get the length of small divided by the length of big, that whole thing squared. Okay, so in this case, I know that my area is 3 over 27, and that's going to equal my scale factor, that quantity squared. This simplifies to 1/9, and this becomes 1/9. So let's kind of apply this and kind of see what we can do with this. Let's take a look at number 1. What it says, for each pair of similar figures, find the area of the shaded region. So I want to find this area here. All right, so I want to find area. I'll call this X. Call area of shaded region region x is equal to x. All right. So what I know is I have a similarity ratio. All right. My similarity ratio ends up being 11 divided by 44. And if I simplify that, I can get 1/4 is my similarity ratio. Okay, so if I take the area of the small, I'm going to take 20, all right, that's my area of the small. I'm going to divide that by the area of my shaded region, x. And that is going to equal my scale factor squared. Okay, so what I can do here is I now have a proportion. Now, if I want to take 1/4 squared, then that means I have 20 over x is equal to 1 squared divided by 4 squared. All right, so now I get 20 over x is equal to 1 over 16. Okay, and this allows me to solve for x, and I can actually find the area of that shaded region. So I'm going to take 20 times 16 is equal to x times 1. So x times 1 is just x, and then 20 times 16 is going to give me 320 meters squared, and that's the area of my shaded region, okay, up here. All right, so I'm just following the formula that I have here. All right, area of the small divided by area of the big equals the length of small, length of big, and this is my scale factor. Okay. All right, let's take a look at this next one. Same thing. For each pair of similar figures, use the given areas to find the scale factor from the unshaded to the shaded region. Okay. So it doesn't really matter how we go about doing this, how we set it up, whether we want to go big to small or small to big. But here's the thing I want to write. Okay, I'm going to take the area of the big, okay, or area of the shaded, which is 4590. And I'm going to divide that by 510. Okay, and that's this area divided by this area, and that's going to equal my scale factor, which is 21 over x, that whole quantity squared. Okay, now this is going to get a little rough as far as the algebra goes. The numbers are just pretty big. You're going to need a calculator for this. But here's what I'm going to do. I'm going to solve this. So I've got 4,590 divided by 510, and that's going to equal 21. That's going to equal 21 squared divided by x squared. Okay, so let me do the math here. 4590 divided by 510. That's going to give me 441 divided by x squared. And what I'm going to do is I'm going to solve this now. So I'm going to cross multiply. So I get 4,590 times x squared is equal to the product of 510 times 441. Okay, so if I take 510 times 441, that's going to give me 224,910 is equal to 4,590 times x squared. Now, if I divide both sides by 4,590, okay, divide by 4,590, then I end up getting this. I end up getting that x squared is equal to 49. Okay, so that's something you got to do in your calculator. Now, if I take the square root of both sides and solve for x, then I end up getting that x is equal to 7. Okay, and that's pretty nice. Now, let's go back up here. This value here is equal to 7. Okay, and it wants to find the scale factor from the unshaded region to the shaded region. Okay, and so we know that the scale factor, all right, scale factor is going to be from unshaded to shaded, so it's going to be 7 to 21, so which is really 1 to 3. Okay, that's my scale factor, but we want to solve for x and find what that is, and that was 7. Okay, let's take a look at the next one, the very, very last one. Number 3, the science project. My friend Matt has 2 posters for his science project. Each poster is a rectangle, okay, and they're similar. So let's go ahead and let's actually just draw in 2 rectangles, one that's big, one that's small, okay, and it says the length of the larger poster is 11 inches. So I'm going to call this 11 inches. The length of the smaller poster is 6 inches, so this is 6 inches. Okay. What is the area of the smaller? Okay, so find the area, and I'll call that x. Okay. If the larger poster is 93.5 square inches, so area is equal to 93.5 inches squared. Okay. The length of the smaller poster. Okay. So here's what I want to do. I know that the area of my big is 93.5, and I'm going to divide that by x. And this is going to equal my scale factor, which is 11 divided by 6, that quantity squared. So if I simplify this and solve for x, which is my area of the small one, I get 93.5 over x is equal to 121 divided by 36. Okay? So what I can do is I can set up I got a proportion. I can solve this proportion. So I'm going to take 121 times x is equal to 36 times 93.5. Okay, so I get 121x is equal to, what is that, 3,366? All right, and if I divide that by 121, I end up getting that x is equal to 27.82 units squared. And that's going to be the area of the smaller one. Okay, that's the area up here. So again, guys, I'm just setting up this proportion each time. Area of the big over area of the small is equal to the scale factor, that whole thing squared. Okay, if you're able to do that and use your algebra, you should be just right fine with this. So hope you enjoy, and let's go ahead and get started on the homework for 11.5. Thank you.